Hi, today we are going to talk about writing conclusions using the CER method, okay? And we have discussed this previously, but we're going to take some actual notes on this today. You can find these notes on slide 30 and 31 in your inquiry INB. Most of these notes are already written for you, but there will be some things that you need to write in the left-hand column as we go along, and there will be a stop sign every time you need to do something in your notes. So please make sure that you have your INB open in another tab, and make sure that you're looking at slide 30 and 31. Okay, so the essential question for this set of notes, by the end of these notes, my hope is that you will be able to answer this question. How do scientists use their data? How do scientists use data to draw a conclusion to their inquiry investigation? How do scientists use their data to draw a conclusion to their inquiry investigation? That is the question that you should be able to answer by the end of this set of notes. Okay, so scientists explain themselves and write conclusions using the CER method. Okay, so the CER method is something that scientists use to explain themselves and write conclusions. A good conclusion should include 3 parts. A claim, okay, that's what the C stands for. Evidence, that's what the E stands for, and reasoning, that's what the R stands for. So that's why we call it the CER method, okay? We call it the CER method because every good conclusion or explanation includes a claim, evidence, and reasoning. And we're going to talk about what those 3 things are here on the next few slides. Okay. So how do you write your claim? So when you write a claim, okay, your claim should state whether your hypothesis was refuted or supported, okay? So when you make your claim, you need to say whether or not your hypothesis was refuted or supported. What does that mean? Well, if your hypothesis was refuted, that means that your data proves your hypothesis wrong. Now, if your hypothesis was supported, that means that the data that you collected backs up the hypothesis. Your hypothesis appears as if it might be correct based on the data that you collected, okay? In addition to this piece, right, in addition to stating whether or not your hypothesis was refuted or supported, your claim should also provide an answer to the original research question, okay? Your claim should also provide an answer to whatever the original research question was. So let's look at an example, okay? So for example, let's pretend that our testable question was this. How does caffeine affect a person's appetite? Okay, how does caffeine affect a person's appetite? And let's say that before you did this experiment, you wrote a hypothesis, you made a prediction, okay? And your hypothesis was this. If people drink caffeine, then their appetite will decrease. Their appetite will go down because they will feel hyper and anxious, okay? So if people drink caffeine, their appetite will decrease. It will go down. Well, if you look at the results of this experiment, here are the results right here. This is the caffeinated coffee group, and this is the decaf coffee group. And over here, we have the number of calories that group consumed per day. So if you look at the caffeinated coffee group, right here, this group ate far fewer calories than this group did, okay? This group, the caffeinated group, ate fewer calories than the decaf group, okay? So it appears that our hypothesis was correct, right? Or at least our hypothesis was supported, right? The prediction was that if people drink caffeine, their appetite will go down. They will eat less. And if you look at the caffeinated coffee group, they certainly ate fewer calories than the decaf group. So it looks like our hypothesis is supported, okay? We can't necessarily prove it to be true, but our data backs up our prediction. So to write your claim, you would write something like this, and I highlighted my claim in yellow. According to the data, my hypothesis was supported. Okay, my hypothesis was supported. And then I need to go back and I need to actually answer this testable question. How does caffeine affect a person's appetite? Okay, well, according to my data, my hypothesis was supported. The data suggests that people who drink caffeine have less of an appetite. Okay, so that is my claim. It's a 2-sentence claim. According to my data, my hypothesis was supported. Okay, the data seems to back up my prediction. The data suggests that people who drink caffeine have less of an appetite. That is the answer to my original question. Okay, so this is an example of a good, solid claim. Okay. Okay, so now what I want you to do is I want you to stop, pause the video, and on slide 30, your writing conclusion CER notes in the left-hand column, I want you to summarize for me. Tell me what is a claim, okay? What is a claim? And then I want you to use your own words to explain it, okay? So explain to me in your own words what a claim is. And you can do it on the left-hand side of your notes or the right-hand side of your notes, okay? But this is on, you're doing this in the left-hand column, okay, of slide 30, okay, in the INB. So go ahead and pause the video and do that. Okay. So providing evidence. So after you write your claim, the next step when you're writing a conclusion or a scientific explanation is to provide evidence, okay? So it's really important to include multiple pieces of evidence to support your claim. You don't want to just have one piece of evidence. Remember that you're trying to convince somebody that your claim is true. So you're going to need multiple pieces of evidence. So what counts as evidence? Okay, what counts as evidence? Well, to provide evidence, one thing you can do is describe your observations, right? Just in general, just like in general, okay? In general, describe your observations, okay? Maybe, for example, talk about some general patterns in the data, okay? General patterns that you notice. The other thing that you should do, that you really must do, is use quantitative data whenever possible, okay, to show how the IV affects the DV, okay? So in other words, compare numbers. Compare numbers from your graph or your data table, okay? So in other words, when I say use quantitative data, that means I want you to take numbers. Take some numbers from your graph or from your data table and compare them to show me how the IV affects the DV, okay? Support your claim with numbers from your graph. So here would be an example, right? So here we still have our same graph, right, where we've got caffeinated coffee on the bottom and decaf coffee over here. So 1 bar for caffeinated, 1 bar for decaf. This group consumed less or fewer, I guess, calories than the decaf group. And you can see that because the bar is shorter, right? And this is the number of calories over here. So when we go to provide evidence, our first piece of evidence might be something like this, right? As you can see in this graph, the decaf coffee consumed less calories than the caffeinated coffee group, okay? So decaf coffee consumed less calories than the caffeinated coffee group. Okay, so this piece of evidence right here kind of just talks about the general patterns in the data. Okay. Another piece of evidence to support our claim would be something like this. Okay. The decaf group consumed an average of 3,000 calories per day, whereas the caffeinated group consumed an average of only 1,500 calories per day. Okay, this would be another piece of evidence that supports our claim, and this piece of evidence is quantitative. Quantitative, okay? It relies on comparing numbers. Comparing numbers from our graph, okay? So both of these pieces of evidence, the evidence that relies on patterns, okay, and the evidence that relies on comparing specific numbers from the graph, both of these pieces of evidence support our claim that drinking caffeine reduces your appetite. Okay, so now what I would like you to do is I would like you to pause the video, and on slide number 31 in your INB, okay, it's the second slide of conclusion CER notes. I would like you in the left-hand column, okay, probably on the left side of the slide, in the left-hand column of your notes, I would like you to explain why scientists need to include evidence in their conclusions. Why is it important for scientists to include evidence when they are writing a conclusion? Okay, so you're doing that in the left hand column of slide 31 in your INB. Okay? Okay, so the last step when you are writing a CER conclusion to an inquiry investigation is to explain your reasoning. Okay? So when I say explain your reasoning, what I mean is you need to use your science knowledge to explain why your evidence supports your claim. Okay? In other words, you need to link the evidence to the claim using science concepts. Okay? So science concepts or science knowledge that you use in your reasoning could include facts that you learned from science class, maybe some background research that you did, or you could even use the results of other experiments to link, okay, your evidence back to your claim. So let's look at an example. So here we have that same graph, okay? Again, we've got our caffeinated coffee down here, our decaf coffee over here. The caffeinated coffee group consumed less calories per day, okay? So same results here, but now I need to provide my reasoning, okay? So I've already given my evidence, right? And I've already made my claim. My claim is that people who drink caffeinated coffee will consume less calories, right? They don't have as great of an appetite. And my evidence is that the people who drank caffeinated coffee didn't eat as much. They consumed fewer calories. In fact, they consumed about half the number of calories as the decaf group. That's my evidence, okay? Now I need to explain why the caffeinated group may have eaten less calories than the decaf group, okay? So here I've got my reasoning, right? The caffeinated group probably consumed fewer calories because caffeine makes your heart rate go up, okay? Maybe I learned in science class that caffeine makes your heart rate go up, and this causes anxiety. And I also know from some background research that I did that people don't eat much when they are anxious, okay? So this would be an example of some reasoning, right? Heart rate goes up, heart rate going up causes anxiety, people don't eat much when they're anxious, okay? This is the reasoning, okay, that explains why my evidence supports my claim. Okay, so now that we understand the three different parts of the CER process, right? C is for claim, E is for evidence, and then R is for reasoning. Once we have our three different pieces of information, now we need to put it all together, okay? So when you put it all together, what you need to do is you need to write up your conclusion in paragraph form, right? So instead of having your claim, and then your evidence, and then your reasoning, you need to put it all together into a paragraph. And you want to write your paragraph in order. So you want to start with your claim, then provide your evidence, and then finally provide your reasoning. And then to end your paragraph, you usually want to restate your claim at the end. Okay? So here's an example of how to put it all together. Okay? So basically I just took my claim, my evidence, and my reasoning that I wrote, and I put it all into one paragraph. And then I ended by restating my claim. So my claim is highlighted in yellow, and I wrote my claim at the beginning and restated it at the end. My evidence is highlighted in this orangish color, and my reasoning is highlighted in blue. Okay, so if we read this whole thing now, this is what my conclusion paragraph sounds like. According to the data, my hypothesis was supported. The data suggests that people who drink caffeine have less of an appetite. As you can see in this graph, the decaf coffee group consumed less calories than the caffeinated coffee group. The decaf group consumed an average of 3,000 calories per day, and the caffeinated group consumed an average of 1,500 calories per day. The caffeinated group probably consumed fewer calories because caffeine makes your heart rate go up. This causes anxiety, and people don't eat much when they are anxious. In conclusion, the data suggests that caffeine suppresses your appetite. So now we have this nice CER conclusion paragraph that we made by combining all of the parts together. Okay, so now what I would like you to do is I would like you to stop the video. This is the end of the video, and I would like you to do two things, okay? I want you to go back and I want you to highlight key vocabulary words in your notes. So go back to slide 30 and 31 and go through all of the notes that we just covered and highlight any key vocabulary words that you think are important. The second thing I would like you to do, and this should say number 2, sorry. The second thing I would like you to do is on slide 31, okay? On slide 31 in the left-hand column of your notes, I would like you to write down one question that you still have about writing conclusions, okay? And if you can't think of a question, you feel like you really get it, then come up with a question that you think I might ask you on a quiz, okay? All right, great job, everyone.